Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video we will solve together a new problem. This is problem number 3. Given the function f defined over 0 plus infinity as f of x equals x minus 1 plus 1 plus ln squared x over x, and designate by c its representative curve in orthonormal system. First question, calculate limit f of x as x goes to plus infinity and limit f of x as x goes to 0 plus. As x goes to plus infinity, 1 plus ln squared over x goes to 0 because x is faster than 1 plus ln squared x as x goes to plus infinity. We still have here plus infinity. Limit f of x as x goes to 0 plus f of x as x goes to 0 plus. Here we have ln x minus infinity squared plus infinity over 0 plus is plus infinity, and here we have 0. This is what also plus infinity. What do we notice here? Limit f of x as x goes to a equals infinity, then we have a vertical asymptote. Vertical asymptote x equals 0. Prove that thus the line delta with equation y equal x minus 1 is an oblique asymptote to c. First we have limit f of x as x goes to plus infinity equals plus infinity. How to prove that delta is an oblique asymptote? We find the limit of f of x minus y of delta. This limit will be equals how much? Will be equals to 0. If we subtract x minus 1 from f of x, we still have 1 plus ln squared x over x as x goes to plus infinity, which is 0. And of course, limit f of x as x goes to plus infinity equals plus infinity. To prove an oblique asymptote, we have to prove two things. Limit f of x as x goes to plus infinity equal plus infinity, and limit f of x minus y delta equal how much? Equal 0. Show that c is above delta. Show that c is above delta. It means f of x minus y of delta should be greater than 0. Let us see. Then f of x minus y delta is 1 plus ln squared x over x. This is positive because x is positive and this quantity in the numerator is positive. So this is positive. Then c is above delta. We have to prove that f prime of x equals x squared minus ln x minus 1 squared over x squared. We have f of x minus y delta equals 1 plus ln squared x over x. We can find the derivative from this equality. Derive both sides. F of x, f prime of x, y of delta is x minus 1, derivative 1. So f prime of x minus 1 equals, so if we derive both sides, we get f prime of x minus 1. Here we have u over v, u prime v minus uv prime over v square. Okay, the derivative of ln squared x is 2 ln x over x times x, and so on. This is minus into ln x minus 1 square over x square. Because here, if we take minus common factor, we get ln squared x, so minus common factor, ln squared x minus 2 ln x plus 1. This is the form of a minus b square. F prime of x equals, we transfer minus 1 to the other side, so 1 minus, making a common denominator, x squared minus ln x minus 1 square over x square. Write an equation of the tangent T to C at the point A of abscissa E and verify that T is parallel to delta. Okay, how to write the equation of the tangent A of abscissa E? Then the slope of T is alpha prime of E. Alpha prime of E equals 1. Alpha prime of E equals 1. The slope of T, okay, and the slope of delta is also 1. Then the tangent is parallel to delta. We have to calculate f of E because the equation of the tangent is y minus y point equals slope into x minus x point. So we have to calculate the y of that point. Y of the point is f of E because the point belongs to the curve of the function. F of E equals E minus 1 plus 1 plus ln squared E over E. Ln E equals 1, ln squared E equals also 1, then E minus 1 plus 2 over E. Equation of the tangent, we substitute, so we get y equals x plus 2 over E minus 1. Slope of T equals 1 equals slope of delta, then T is parallel to delta. The curves below represent the curve of the functions defined as. So we have two curves, and their functions are given by y equal x minus ln x plus 1 and y equals x plus ln x minus 1. Okay. Which one is the equation of h and which one is the equation of h prime? Okay. Here in h the curve cuts x prime x. In h prime the curve doesn't cut x prime x. And with respect to the curve h, it cuts the x-axis at 1. So we should have y of 1 equals 0. Okay, if we take the equation y equal x minus ln x plus 1, y of 1, 1 minus ln 1, 0, 1 plus 1 equals 2, different from 0. Then this equation is not the equation of h, it will be the equation of h prime. And the equation of h will be x plus ln x minus 1. If we substitute here x by 1, we get 1 plus ln 1, 0, 1 minus 1 equals 0. Or we can use the derivatives of the functions. Here we have the function in h, in curve h, the function is increasing. We find the derivative. The derivative, when the derivative is positive, it will be what the equation will be, the equation of h. Let us see. If y equal x minus ln x plus 1, y prime equal 1 minus 1 over x. And if y equal x plus ln x minus 1, y prime equals 1 plus 1 over x greater than 0. Then y equal x plus ln x minus 1 should be the equation of h. The other equation is the equation of h prime. Study the sign of h of x, of g of x equals x squared minus ln x minus 1 squared. Here we have x squared minus ln x minus 1 square has the form of a square minus b square. So this is a minus b into a plus b, x minus ln x plus 1 into x plus ln x minus 1. Same sign as x plus ln x minus 1, because x minus ln x plus 1 is the equation of h prime, which is positive because the curve h prime is above x prime x. And the sign of x plus ln x minus 1 over 0, 1 over 0, 1, y is negative, over 1 plus infinity, y is positive. Okay, so this is the sign table. Over 0, 1 over 0, 1 negative, and over 1 plus infinity positive, and at 1 is 0. Set up the table of variations of f. F prime of x is what? X squared minus ln x minus 1 squared over x squared takes the sign of x squared minus ln x minus 1 squared, which is g of x. Then the sign of f prime of x is the same as g of x. So minus plus. Then the function f decreases, then increases. Limit f of x as x goes to 0 plus is a plus infinity. As x goes to plus infinity, and we have an oblique asymptote 1, 1. The curve c prime below represents the curve of f prime, the function derivative of f. And d is the straight line of equation y equal 1. Verify that d is tangent to c prime at the point k of abscissa E. D, this straight line d, is tangent to c prime at the point of abscissa E, and c prime remains below d. Let us see. Yc prime minus yd is f prime of x minus 1, seen before, equals to minus into ln x minus 1 square over x square. This quantity is negative for x different from e, because if x equal e, ln x minus 1 equals 0, and we have ln x minus 1 2 times, so x equal e is a double root. Hence the straight line d is tangent to the curve c prime at the point of abscissa E, and the curve c prime still below the straight line d. Deduce the sign of f second over the interval e minus theta e plus theta, where theta is a very small positive number, and that the point I of abscissa E is an inflection point of C. Curve C prime goes up to touch the straight line D at the point of abscissa E, then goes down because its curve is below the straight line D. Then over a neighborhood of E, the function f prime is increasing, then decreasing. The table of variation of f prime over the interval e minus theta e plus theta we know that f prime of x, f prime increases over e minus theta e, then decreases. So f prime of x increases to 1, then decreases. So the derivative of f prime should be positive over e minus theta e, and it is 0 at e because we have a horizontal tangent, and negative over e plus theta. Then the second derivative vanishes at e and it changes the sign. Therefore, the point I of abscissa E is an inflection point of the curve C. Calculate f of 0.5 and f of 2, then plot delta t and c. F of 0.5, we substitute x by 0.5. Making use of your calculator, you get 2.46. F of 2, also making use of the calculator, equals 1.74. Here is the curve of C, because it decreases, then increases, and we have an oblique asymptote. This is the oblique asymptote, and this is the tangent. The tangent cuts the curve. At point of abscissa E, the tangent cuts the curve, and the tangent is parallel to what? Look here, the curve C is above the tangent, and here the curve is below the tangent, and the curve goes to the oblique asymptote. Okay. Study according to the real parameter m, the number of the roots of the equation ln squared x plus x squared minus 1 plus mx plus 1 equal to 0. This equation is called E, and x of course is positive because we have ln x. To make this equation as intersection of the curve with a variable straight line, let us see. Okay, then this equation becomes ln squared x plus 1 over x plus x equal 1 plus m when we divide by x. Divide by x. Okay, take 1 to the first side. We got what? This is f of x equal m. What does it mean, f of x equal m? As we want to study the intersection between the curve of f and the variable straight line of equation y equal m, this straight line is horizontal. Here the minimum is 1 1 is the straight line if m equals 1, so we have a double point in common between them. If m greater than 1, the straight line cuts the curve in two distinctive points. If m less than 1, the straight line doesn't cut the curve. Okay, thanks for following and good luck.